Welcome to this comprehensive guide on C# serialization, a fundamental concept for managing data in your applications. Understanding serialization is crucial for any C# developer, as it forms the backbone of how data is persisted, exchanged, and restored within and between different software components. This guide offers a beginner-friendly approach to mastering this essential skill, ensuring you can effectively handle data in your projects. Serialization is the process of converting an object, an instance of a class containing data, into a stream of bytes. This transformation makes the object state ready for operations like saving to a file, storing in a database, or transmitting across a network. It flattens the complex structure of an object into a linear sequence of data, easily handled by storage or communication mechanisms. Conversely, deserialization is the reverse process, taking that stream of bytes and meticulously reconstructing the original object. All the data and structure are restored to their previous state, making it fully functional and usable within your application again. It's like rebuilding a complex structure from a blueprint, ensuring every detail is accurately put back into place for seamless operation. This capability is crucial for several core programming tasks. It allows saving object states, like user preferences or game progress, for later loading. It facilitates transferring data between systems, such as sending information via an API. Moreover, it's vital for maintaining data integrity and consistency across different environments, ensuring data remains valid and usable regardless of its storage or processing location. In C#, we primarily work with three distinct types of serialization, each suited for different scenarios and offering unique advantages. These are binary, XML, and JSON serialization. Binary is efficient and compact. XML excels in human readability and interoperability, while JSON is widely adopted for its lightweight nature and broad compatibility, especially in web applications. We will explore each of these in detail. Let's begin by understanding binary serialization, which leverages the binary formatter class for compact and highly efficient data storage. This method converts objects directly into a binary format, making the resulting data stream small and fast to process. It's useful for internal application data where human readability is not required, prioritizing speed and minimal file size over external compatibility. Binary serialized data is inherently not human readable. It appears as a sequence of bytes rather than structured text. This characteristic makes it ideal for internal application use, where efficiency, speed, and data obfuscation are primary concerns. Its non-readable nature is a benefit, ensuring quick storage and retrieval within a controlled environment, as external systems won't typically interact with this raw binary output. To enable binary serialization for your custom classes, you must explicitly mark them with a serializable attribute. This attribute signals to the .NET runtime that instances of this class can be converted into a binary stream. Without it, the binary formatter will throw an exception, indicating the class is not eligible. It's a critical declaration preparing your object's blueprint for this specific data transformation. For beginners, correctly applying the serializable attribute is the first essential step to prepare your objects for binary serialization. It acts as a prerequisite, a foundational element telling the system, yes, this object is designed to be serialized. Forgetting this simple attribute is a common pitfall, so always remember to include it at the top of your class definition when working with binary formatter. Binary serialization fundamentally involves using the binary formatter class with a file stream to manage reading and writing byte streams. The binary formatter handles object conversion to bytes and vice versa. The file stream interacts with the file system. Together, they create a robust pipeline for efficiently persisting and retrieving object states from disk. Next, we explore XML serialization, a method producing human-readable XML output, significantly different from binary. It converts C# objects into a structured XML document, where data is represented using tags and attributes easily understandable by humans and other systems. This human-readable nature makes it an excellent choice for configuration files, data exchange, and scenarios requiring easy data inspection. XML serialization, primarily utilizing the XML serializer class, is exceptionally well suited for achieving interoperability. This means different computer systems can easily exchange and use information. By generating standardized XML documents, XML Serializer allows disparate systems to exchange data in a universally understood format. This makes it a cornerstone for web services, data feeds, and cross-platform communication. A powerful feature of XML serialization is the ability to precisely control the structure of the XML output using various attributes. For instance, XML element can rename an element. XML attribute serializes a property as an attribute, and XML array customizes collection representation. This offers immense flexibility, allowing you to tailor the XML to specific schema requirements or external system expectations. XML serialization typically employs the XML Serializer class, with StreamWriter and StreamReader for efficient XML file handling. The StreamWriter writes serialized XML data to a file, and the StreamReader reads XML data, which XML Serializer then deserializes back into an object. This combination provides a robust way to persist and retrieve object data in a human-readable XML format. Finally, let's delve into JSON serialization, a method incredibly popular and widely prevalent in modern web applications and APIs. JSON, or JavaScript Object Notation, is a lightweight data interchange format, easy for humans to read and write, and for machines to parse. Its simplicity and efficiency have made it the de facto standard for data exchange in web services, mobile applications, and single-page applications, driving widespread adoption. JSON serialization in C#, powered by the system.text.json namespace, is highly regarded for its simplicity and broad support across platforms. Introduced in .NET Core system.text, JSON offers high-performance and memory-efficient serialization, making it the recommended choice for new applications. Its native integration ensures developers can easily convert objects to JSON and back, facilitating seamless data handling. Key methods within system.text JSON include JSON Serializer, serialize for converting C# objects into JSON strings, and JSON Serializer, deserialize for the reverse, reconstructing objects from JSON strings. These methods are straightforward, often requiring just a single line of code for complex data transformations. They are the workhorses for JSON data handling, providing a clear and efficient way to manage data flow. While system.text JSON is the modern standard, Data Contract JSON Serializer provides an alternative for JSON serialization, particularly relevant in older frameworks or enterprise scenarios. It's part of the system, runtime, serialization, JSON namespace, and often used with Windows Communication Foundation or WCF services. Understanding its existence is important when working with legacy codebases or projects not yet migrated to system.text JSON. Now that we've covered the three main types of serialization in C#, let's transition to some helpful tips and best practices for effective serialization. These insights are designed to help you avoid common pitfalls, optimize your processes, and build more robust and secure applications. Applying these tips will significantly enhance your understanding and practical implementation of serialization techniques in your C# development journey. A crucial tip is to use the non-serialized attribute to explicitly exclude specific fields from binary serialization, preventing unnecessary data storage. This is useful for fields holding temporary data, calculated values, or sensitive information that shouldn't be persisted. Marking these fields ensures only relevant data is serialized, leading to smaller file sizes, improved performance, and enhanced data security. Always consider version control when serializing objects, especially as your class structure evolves. Properties might be added, removed, or renamed, potentially breaking compatibility with previously serialized data. Implementing versioning strategies, like using optional field for new members or carefully managing schema changes, is vital to ensure older serialized data can still be deserialized successfully by newer application versions, maintaining backward compatibility. Implementing robust error handling is paramount to gracefully manage issues during both serialization and deserialization. Data corruption, malformed input, or unexpected data types can lead to exceptions. By wrapping your serialization and deserialization calls in try-catch blocks, you can catch these errors, log them, and provide meaningful feedback, preventing application crashes and ensuring a more resilient user experience. Be extremely cautious about security when deserializing untrusted XML data, as it can pose significant vulnerabilities. Malicious XML payloads can lead to attacks like XML external entity or XXC, injection, denial of service, or information disclosure. Always validate and sanitize XML data from untrusted sources before deserializing, and consider secure deserialization settings or alternative formats like JSON to mitigate risks. To maximize efficiency, optimize your data structures, ensuring only necessary data is serialized. Avoid serializing large, complex objects when only a subset is required. Consider creating data transfer objects, or DTOs, containing only properties needed. This practice reduces processed data, leading to faster serialization and deserialization times, and minimizes storage footprint, especially for frequently serialized objects. This optimization of data structures directly translates into significant benefits: reduced file size, quicker data transfers, and lower storage requirements. Furthermore, it dramatically improves performance, especially with large datasets or high-frequency serialization operations. Smaller data payloads mean less network bandwidth, faster disk I/O, and reduced memory usage, all contributing to a more responsive and scalable application. Understanding these diverse serialization techniques, binary, XML, and JSON, is vital for any C# developer aiming to build robust and efficient applications. Mastering these concepts empowers you to effectively manage data persistence, facilitate inter-application communication, and ensure data integrity across various systems. This knowledge is a cornerstone for developing scalable, maintainable, and high-performing software solutions. Thank you for watching this comprehensive guide on C# serialization. We hope this detailed explanation has provided a clear and solid foundation for your learning journey, covering binary, XML, and JSON serialization, along with crucial best practices. We encourage you to experiment with these techniques in your own projects to solidify your understanding and continue exploring C# data management.